Welcome back. We're talking about functions here. And what we're going to do is we're going to start with a function. We're going to write the domain and range of it just for a quick refresher. And then we'll move on to some applications to show the usefulness and actually the power of functions. So let's go ahead and take a look. Let's say we have the function f of x equals x squared. Okay? And we want to know the domain of the function, and we want to know the range of the function. Now recall what the domain is that the domain is the set of all numbers that we can actually plug into this function, the set of all inputs that we can substitute in for x, and the range is the set of all outputs. So whatever we put into the function, we get an output, and the set of all of those outputs is called the range. These are all possible inputs and outputs, if you want to think of it like that. In this case, we're actually not told anything about x, so we can assume that, or we're going to assume that x can take on any real value. The value of f of x will always be non-negative, whether x is positive or negative. And this makes sense because no matter what number that we put in here for x, we're going to square it, so we can't get a negative number. The lowest number we can actually get is 0. We can plug in 0, and 0 squared is just 0. But even if we put in negative numbers here, we'll still get a positive output. So the domain here is the set of all real numbers. We can put in any real number into this domain, and it's going to spit something out. And the range is the set of all non-negative real numbers. Non-negative real numbers. Most of the time I'll just abbreviate real numbers as reals. But the range is a set of all outputs. So no matter what we put in here, it's going to spit out a non-negative number. Okay, so that makes sense. So let's look at a few applications of this. Let's say a marble is dropped from a height and it bounces up to 50% of its original height. Okay, so we drop it from some unknown height, and it bounces up to 50% of whatever that original height is. So we have f of x, and first, well, before we write our function, we have to define our variable. So we're going to let x equal the original height. The original height. This is the height that we're dropping it from. So 50% of the original height will be 0.5x. Whatever height we drop it from, it's going to bounce up 50%. So we're going to multiply 50% or 0.5 times the original height to get our answer. Now we want to identify, the domain and the range. The domain is the set of all possible numbers that we can substitute in for x, for the original height. Well, first of all, we can't plug in a negative number. We can't drop it from -1 foot off the ground. That doesn't even make sense. And we're told that we're actually dropping it from some height, so we can't plug in 0 either. If we drop it from a height of 0, it's just sitting in its original spot. So the domain is going to be the set of all real numbers, greater than 0. So any number greater than, even if it's just a fraction, just a half of a foot. Even if it's just a half of a foot, it's still going to bounce up 50% of that original height. Now the range is going to be the actual height that it bounces up to. And that too is going to be the set of all real numbers greater than 0. Because if we drop it from, let's say, the height of 1 foot off the ground, it's not going to bounce up a negative amount of feet. It's just going to bounce up 50% of whatever height that we dropped it from. Okay, so functions are very useful, but sometimes this is actually the first case in mathematics where you actually have to do a little bit of thinking. It's not just simply solving something. We actually have to think about what's going on, which is actually really good. So let's look at a few more of these. Let's say Peter rents a car for $100. The rental company charges him $100 and also charges him $1 per mile. $1 per mile. Okay, and it says we're going to round to the nearest mile. So we round to the nearest mile, and that's going to be useful when we're doing our domain and range. Going to round to the nearest mile. Okay, so we want to set up a function for this situation. So let's go ahead and define our variable x as the number of miles driven. So the number of miles driven is going to be our variable x. So f of x, or the function of x, is going to be 100. They're charging us a flat rate of 100 plus 1 times the number of miles. That's how we're going to figure out our entire bill, is the $100 flat rate plus $1 for each mile we're driven. Well, x is the number of miles, so it's going to be 1 times x. And if we clean this up a little bit, we can drop the 1 as the coefficient and just write x plus 100. So f of x equals x plus 100. So this is our function describing this financial transaction. Now, as far as finding our domain and our range, values have to be 0 or positive, because Peter can't drive a negative amount of miles. So there must be actually a maximum number of miles as well, because there's only so much time in the day for him to drive, or he runs out of gas money, etc. But since we're not giving any of this information, we must just consider that all non-negative integers could be possible regardless of how big they are. They're not giving us any limit on the possible values, but they definitely have to be 0 or positive. They can't be non-negative. So the domain is going to be the set of all non-negative integers. And we say integers because, again, we're rounding to the nearest mile. If we weren't rounding to the nearest mile, then he could be charged for half a mile that he's driven. So it would be the set of all non-negative rational numbers. Okay, but here, since we're rounding to the nearest mile, the domain, or the possible number of miles he can drive, is the set of all non-negative integers. Now the range, no matter what number we put in here, the range is going to be greater than or equal to 100. We're never going to get less than 100 because the flat rate is $100. So even if he rents the car, doesn't drive it a mile, so he's not incurring any of this charge, he's still going to be charged $100 because that's flat rate. So we're going to have our range as the set of all integers, and again they're integers because we're rounding to the nearest mile, or non-negative, so all integers greater than or equal to 100, because we can actually have a charge of $100, and that's if he just doesn't drive anything and our number of miles is 0. If we plug in 0 for x, 0 plus 100 is 0. Or excuse me, as 100. So all integers greater than or equal to $100 is the range for the function of this transaction. Okay, so he can be charged more than $100 depending on how many miles that he drives. So it's a really good application of using a function, and it's actually very helpful if you're renting a car in the near future. Let's look at a few more. Let's say Peter charges $12 an hour. $12 an hour for tutoring math. Let's say he's a math tutor and charges $12 an hour. Instead of writing a function this time, let's go ahead and identify the domain and the range. We'll do some more practice on writing functions maybe in a later section. But the domain here is going to be the set of all non-negative. They're non-negative because Peter can't tutor for a negative amount of hours. Time is always positive in this sense. So non-negative rational numbers. Now we're including the rational numbers here because it's possible to tutor for a half an hour or an hour and a half. Rational numbers is a subset of integers, being that any integer is just a rational number with a denominator of 1. Okay, so non-negative rational numbers is our domain. Our range which is actually the amount of money he makes, which is dependent on our domain, our range is actually going to be the same. Range is going to be the set of all non-negative. They're non-negative because he can't earn a negative amount of money. Non-negative rational numbers. And they're rational numbers because if he works a fraction of an hour, he can actually get paid some dollars and some change, which is essentially a rational number. A dollar, whole amount of whole dollars, and a fraction of a dollar, so like 50 cents or something like that. So domain and range are both non-negative, the set of all non-negative rational numbers for Peter, who tutors math, which is one of the best professions in my opinion. Let's look at one more. Let's say Paul charges $20 for mowing lawns. He has a lawn care business. He charges $20 with a minimum charge of $10. Okay, so he's mowing lawns, charges $20. It's actually $20 per hour, $20 an hour for lawns with a minimum of $10. So no matter how quickly he does it, how small your lawn is, you're going to get charged at least $10. So let's hope he does a good job, because it's actually it's actually a pretty good deal. So let's say the domain is going to be the set of all non-negative integers. The set of all non-negative integers. This makes sense because he can't mow, for his business, he can't mow a negative number of yards. He can't mow -2 yards in a day. So it's going to be non-negative, and it's going to be the set of integers. Integers meaning he can't mow just half a yard. He's expected to mow 1 yard or 2 yards or 5 yards or 10 yards, however many yards he has to mow. So the set of all non-negative integers, integers including 0. 0 is a non-negative integer. He can actually take the day off and not mow anything. Okay, now our range is the amount of money he makes. Our range is going to be the set of all integers greater than 10. So the set of all integers greater than 10. So he can actually make $10, but the amount he's going to charge somebody is going to be at least $10. So that's the minimum charge. So, and he's not going to charge somebody for half a lawn because, like we said, he's not going to mow half a lawn. So it's going to be the set of all integers greater than 10. Greater than 10. And, well, we're actually, since we changed this to $20 an hour, we're going to make this the set of all rational numbers. The set of all rational numbers greater than 10. And here's why. Because no matter how it depends on how long it takes him to mow a yard. So if he mows a yard in an hour and a half, he's going to get paid actually a fraction amount of dollars. You know, just like up here, if your pay is based on an hour, you're going to get paid in some dollars and cents, which isn't technically a rational number. So our range here would actually be rational numbers greater than 10. So we're going over functions here. We're looking at real-life application of functions, and we're starting to see the usefulness of using functions. We don't have to keep writing the same equation over and over. We can actually just write it as a function and then plug in the independent variable, and it'll actually spit out just some number. The input's the domain and all the possible domain, and the output is all the possible range. So we're learning its components, we're learning how we use it, and we'll talk about functions much more in the future. I'll see you soon.